Well, let's see. Yes, it's still good morning. Good morning. My name is Dr. Pomponi, and this is Miss Conkling, and we both work at Harbor Branch Oceanographic Institute. Do you know about Harbor Branch? Has anybody been to Harbor Branch? Oh, okay. Have you been to the Ocean Discovery Center at Harbor Branch? Yep. And it's part of Florida Atlantic University, and we're both marine biologists. And today we're going to, I think you've already learned a little bit about the scientific method. Is that right? You know a little bit about it? All right, we're going to review it. We're going to review the scientific method, and I'm going to teach you, give you some, like a demonstration of how we use the scientific method in our research. We both do research, and we study sponges. So sponges are animals that live in the sea, and the reason we study them is because they're really important. They occur in all different kinds of marine habitats and environments. They're very important on coral reefs. And some of them produce chemicals that can be used to treat diseases like cancer. So we're really interested in studying these. But we're not going to work on sponges today. So we're going to do a relatively simple experiment so we can demonstrate to you how we do our experiments, how we go about asking questions that we want to find answers to, and how we go about answering those questions. So the scientific method, just a series of steps that guide us through the method that we use to ask and answer questions related to our research. So the first thing we do is we figure out what is it that we want to learn about. Now, when Ms. Conkling and I do our research, we want to learn about how different sponges produce the chemicals that they produce and things like that. But today we're going to ask a different question today, and I'll tell you in a few minutes what we're going to do. Then what you do is you do some research. You say, okay, well, this is an interesting question. What do we know about it? What has anybody ever done to study this particular question? And then you say, okay, well, based on what I just learned doing my research, I'm going to see if I can predict what the answer to my question is. So, for example, if my question was, does this sponge produce chemicals that can be used to treat cancer, I would say, I would have to predict that answer. And the answer would be as simple as, yes, it does. Yes, this sponge produces chemicals that can be used to treat cancer. Then we design an experiment, and we figure that's the hardest part. So that's actually the hardest part, trying to figure out how do I test this hypothesis. So that's what it's called. When you try to find an answer to your question, what that's called is testing the hypothesis. And you design an experiment to do that. And we're going to do that today. We're going to design an experiment to answer a question that we're going to ask. And then you then after you design the experiment, then you have to figure out, okay, what do I need? Okay, so you write down what your methods are, what's your procedure or your method, and then you figure out what supplies, what materials or supplies do I need to run my experiment. Sometimes that takes a lot of time because you have to go and order supplies or find them in another room or ask somebody if you can borrow supplies. So that can often take a lot longer than just even designing the experiment. And then you actually run your experiment, and then you record. This is really important. You have to write down your results. And really, you have to write down every step of the way. When you say, okay, what is my question? You write it down. What's my hypothesis? You write it down. What's my procedure? You take good notes. You write that down as well. You're not going to have to do that today. We'll do it up here. But maybe I'll get you to help me write it down. And write down what supplies and materials you used. And the reason you do all of this is that really what you want to be able to, you want to answer your question, but you want to make sure that other people can use your same methods, your same procedure, and come to the same answer that you came to, okay? So you write down then your results as well. And typically, you have to perform your experiment at least 3 times, because the first time you did it, you might get a different result the second time you do it. So you do it 2 or 3 times, usually 3 times, to see if you get the same result. And you record your results, and then you come to a conclusion. You get an answer to your question. Okay? So here's the question that we're going to ask today. What we want to find out is, can we float better in the ocean or in our swimming pool? That's what we want to find out. So this is what we want to learn. Can we float better in the ocean, or can we float better in a swimming pool? And we're going to design an experiment to test that. So we're going to do some research right now. And I don't want you to say anything. I just want you to raise your hands. How many of you know how to swim? Okay, good. Put your hands down. How many of you have ever been swimming in the ocean? Okay, put your hands down. How many of you have ever been swimming in a swimming pool? Okay. All right. And it doesn't matter. So it looks like we've already got a good source of information for our research, because most of you know how to swim. Most of you have been swimming in the ocean, and most of you have been swimming in a swimming pool. So based on your experience, that's our research. Our research today is going to be based on your experience. Based on your experience swimming in the ocean and swimming in a swimming pool, how many of you think that you can swim, that you can float? Oh, that's the other thing. I guess I didn't ask if you can float, because not everybody who can swim can also float. I'm not a really good swimmer, but I'm a great floater. I can float on the surface of the water for a long time, but I'm not a really strong swimmer. How many of you know how to float? You know, when you lay on your back, or okay, good. All right. So, based on your experience, can you float better in the ocean? Who thinks you can float better in the ocean? Okay, put your hands down. And who thinks you can float better in the swimming pool? Okay, so it looks like more of you think you can float better in the swimming pool. So let's develop what we call a hypothesis. So based on what I heard from you, or what I saw from you, it looks like the answer to our question, do we float better in the ocean or in a swimming pool, it looks to me that based on your answers, the answer to that question is we can float better in a swimming pool. Does that sound right to you? Okay, so that's our hypothesis. And I want to just say right from the start, sometimes when you develop a hypothesis, you predict the answer. Sometimes you're right, sometimes you're wrong. Sometimes the answer is what you think it's going to be. Sometimes the answer is not what you think it's going to be. So it doesn't mean right or wrong. It just means that it's not exactly what you thought, or it is what you thought. So that's why we do the experiments. So the way we're going to do this, we're going to develop our methods, our procedure. Now, typically what we would do if we wanted to test this is you'd all get your bathing suits on, we get on a bus, and the first thing we would do is we would go to the closest swimming pool, and anybody who knows how to swim and float would jump in the pool, lay on your back, and we would see how long it takes, if you can float pretty well. Then the next thing I do is get all dried off, get on the bus again, go down to the ocean. We do the same thing in the ocean. Lay on your back in the ocean. Don't get all excited. Yeah. We're going to do that today. We're not going to do that today. What we're going to do is an experiment where we make a kind of like a model. We simulate. We do a kind of a different way, like a laboratory-based way to test that. So the way we're going to do that is we're going to use fresh water. So water that we just got out of the sink, so just regular drinking water. And that's going to simulate or take the place of, substitute for the pool. Okay, so that'll be our pool water. And then we have ocean water, salt water, okay? And we have, instead of, obviously, some of you are small, but nobody's going to be able to swim or float in the things that we're going to use today. What we're going to do is we're going to pour the ocean water in here. It's labeled ocean. And we're going to pour an equal amount of fresh water or pool water in here. So this is our pool. This is the ocean. And then, instead of people, we're going to use just slices of carrots. And what we're going to do is we're going to place a carrot on top of the water. One here, one in the ocean water, one in the pool water. and we're going to see which one floats better. Okay? Everybody understand what we're going to do? Okay. So the materials, so that's our procedure. The procedure is to measure out an equal volume of water. Does anybody know what this thing is called? Yes. What's your name?
Marin.
Marin? What is this called?
A retired cylinder.
What kind of cylinder?
A retired cylinder.
I know. I can see you spelling it out. I know what. Yes. What is it? Graduated cylinder. That's what you meant, right? A graduated cylinder. It's called a graduated cylinder not because it's graduating from elementary school, but because it has little marks in here. And this cylinder, it's a cylinder, okay? And this cylinder will hold 100 milliliters of a liquid. And there are little markings for every, and above 10 milliliters it goes for these. So the little tiny markings are for every milliliter. The bigger ones are for every 5 milliliters, and the big ones for every 10 milliliters, okay? So it's graduated. It's in little grades or gradations, so you can actually measure an equal amount. So what we're going to do, we're going to pour water actually just into a smaller container so it's easier for us to handle because these things are heavy. And we're going to put 50 milliliters of ocean water in here, and then pour it into this. Who knows what this is called?
A measuring cup?
Close. It's a scientific measuring cup. What do you think? You don't know? Who knows what this is called?
I do.
A beaker?
A beaker.
There you go.
It's called a beaker.
I just did a wild
A
guess.
beaker. This also has little markings on it in milliliters. So these are each 100 milliliter beakers. So we have 100 milliliter beakers. Okay, so we pretty much have another important thing is labels. Notice we have labels on everything so we don't get confused, because sometimes when you do an experiment, you might say, oh, what do I have in there? Was that my ocean water or was that my pool water? So you have to make sure you write a little label and put that on you. Okay. In this experiment, we've got our materials are graduated cylinders, containers with pool water and ocean water, 100 milliliter beakers, and carrots. What's different between these two sets of experiments? Yes?
That one's pool water and the other one.
Right, so the kind of water. Does anybody know what that's called? What that's called in an experiment? This is a hard word. It starts with a V.
Evaporation?
That's close. It is, if everything else is the same and one thing changes, there's one thing that varies. So it's called a variable. So when you design an experiment, it's really important to just have one variable, because if you have more than one thing that's different, you won't know what caused the outcome or the results. So in this experiment, everything is exactly the same except for the kind of water that we're testing. And for those of you who are very clever, you'll also know that actually not all of the pieces of carrots are cut exactly the same, same thickness. So there's a slight variation in the size and shape of the carrots as well. But I cut them last night and I didn't cut them all exactly the same. So when we do the experiment, it's really, it would be important to just pick out a couple of carrots that look like they're about the same. Okay, so technically, for anybody watching this on TV, and you clever students here, we do have another variable here, but we're really just the one variable that we're testing. Okay, so let's see, what else? Is that about it? I think that's about it. All right, so, and how much time do we have? When is this class over? 12:30. 12:30, okay. I need for, be patient, you gotta be patient, you gotta be patient, you gotta be patient. A lot of people are going to have an opportunity to do this because we're going to run the experiment 3 times, and we're going to, actually, it'll end up being run 6 times too. It'll end up being run 6 times. So Ms. Conkling and I are each going to run the experiment, and you're going to help us, and we're each going to do it 3 times. So we'll have 6 different results, okay? And at the end, we might do one other experiment if we have time. Okay, so I would like for you, and you on the end to come. I would say maybe not do gloves.
Not do gloves.
Yeah, because I don't think we have
Okay.
enough gloves for 3 classes.
Okay.
But the other thing is that, okay, put your hands down. I need you all to pay attention. And I need somebody, okay, I need 2 people over there. And I need you to put on those glasses. And I need 2 over here. Put on glasses. You can have, why don't you stand on this side of me? Okay? Okay, and water. Normally, we wear gloves when we do our research, but since this is just salt water and drinking water, we're not going to do that because I don't think I have enough gloves for everybody. Okay, so just check me. Just make sure our seawater or ocean water going into the ocean. All right, so there's your ocean. Okay.
Who wants to do the ocean
All right,
water?
I would like for you
Okay.
to
You can do the pool water. Okay?
pour 50 milliliters.
So
put
into the
50
graduated cylinder.
pour
You're
this
going to
in
pour
here,
to
get
50.
up to
See that
50. And
line?
I'd like you to do the same thing.
See
We
it?
want 50 milliliters in here and then pour it in this and then pour it in.
Okay, slow down. There, good. Little over, okay? So we're just going to pour a little bit back in here. You see it? It's right at the 50? Yeah? Okay. Now it's your turn. So right to that line right there.
Everybody can be filmed.
A little bit more.
Not interested.
That's good. A little over. So we're just going to pour it. Okay. So we're going to pour those into the beakers.
Okay?
So you're going to pour yours into here. You're going to pour yours into yours.
Pour it in.
Yep, all of it.
Pour it all the way in. Pour it all the way in here. Uh-huh. Okay. Thank you very much. If you can hand over your glasses to, you don't need, you have glasses on, so you're good.
I only have one over here.
Okay, and, okay, thank you. If you can give your glasses, what's your name? What is it? Untitled. Give your glasses to me. And why don't you come over here? Thank you for your
Thank
help. Thank you for your help. Okay, come over here.
Okay, so here's your carrot. And here's yours. You're going to be doing the salt water, and you're going to do the pool water. I know.
Okay, now very
Not yet.
carefully
Hold on.
place, pick up the carrot, and just place it like this.
Okay, watch
on
her.
the top
You're just
of
going to hold it
the
like this.
water.
You're just going to drop it slowly onto the water, okay?
Just place it
Okay,
on
you
top
can do
of
it.
them. Yeah, just- and
And
it's
see what
okay to
happens.
place it. Okay.
Okay,
Okay.
so that one says ocean, and that one says pool.
All right, this is the ocean. This is the pool.
You'll be able to see. She's going to lift it up.
Okay, thank you. You can take off your glasses and go sit down. Not you, you leave your glasses on. Okay?
You're good. You can take them off.
Take your glasses off. Okay.
Thank you.
All right.
You can put them on the table.
Thank you. Okay, our results. We have two pools and 2 oceans. Do we have anything floating in the pool water?
No.
Okay, how about anything floating in the ocean water?
Yes.
How many?
2.
Okay. Who hasn't done it yet? 1, 2, 3, 4. Boy, girl, boy, girl. Come on over here.
Why don't you just raise?
Oh, you got the drill already, okay. Put on the glasses, please. Okay, I need you to pour. here
Okay.
to
So you're gonna do the
50,
pool water.
50 milliliters.
You're going to do the salt water.
50.
Okay.
So pour this.
See that? It says 50 right there. You
Right?
see that over here? Right there? Okay, so you're going to pour this water up to that line. You're going to pour this up to that line, okay?
Okay, now go ahead and pour it in here.
A little bit more. You're not quite there. A little bit more. Just like a drop. Oop.
Rider.
Don't worry. It's okay. Perfect. Perfect. Okay. So you're going to pour them into your beakers.
Oh my gosh!
That's okay. That's
Oh my
all
God.
right.
Oh my god! I wasn't paying attention.
I know, it comes out all of a sudden, doesn't it? It's kind of hard to do.
Good job.
Sometimes we use other things
Very cold water.
called pipettes. Okay, how's that? Is that good? That's pretty close, isn't it? All right, why don't you go ahead and pour it in there? Okay. Okay, you can take
You
down.
have to wait.
take off
Maybe
your glasses.
you'll get to do it again.
And you've already come up here, right?
Just pour it.
1, 2, 3, 4. Carefully place your carrot just on the top. Don't drop it and just try and place it on the top of the water. Okay? Just pretend that you were going to be floating. What's happening with that one? What's happening with that one?
Over there.
Wow, what's happening with that one?
Abigail.
You know what happened with this one? It's really dry, and when you put it on the top, instead of it sinking, it was still taking up water until it sank. Okay, so same situation. Okay, thank you very much. You take off your glasses. Thanks for your help. Okay, what about with this? What about with this one? What are our results? Are there any carrots floating in the pool water? No. How many carrots? Are there any carrots floating in the ocean water? Yes. How many? 2. Okay, should we do it one more time? What are we going to do? Remember what we do? What did we do? Who remembers what we do? What do we do first?
Which line are you going to go to?
50 milliliters. Okay, so take this ocean water and pour up to that 50 mark. Okay, you might have to hold on to this so it doesn't fall over. And you're going to take the pool water and pour it up to that 50 mark. See what I mean? See what I mean? No teasing. He has to have his concentration.
Nicely done. And then what do you guys do? Ryder and Abigail.
Okay, so we're going to pour this ocean water into this beaker.
There? Yep.
Good, good, good. See, so sometimes it's better to like kneel down like this and look at it because we're looking, so you can see it better over there. Okay. All right, what do we do next? What's the next step in our procedure? What's the next step in our procedure?
Will you carefully put the carrots on top of the water?
Correct.
Thank you.
Okay, so carefully, here, use this.
You're just going to carefully drop it on top.
Carefully put it on top.
See?
It's kind of hard to get your fingers in there, huh?
You have to push it.
Let's see what happens.
It's floating. It's floating. Just like water. You put it in too.
We have a floating pool.
All right, well, what happens? What do you think happened there?
You put it in gently.
You did put it in gently. We're making it wet. But wait, just to make sure we're doing the variables, I'm going to kind of poke on this one too. All right? Make sure, because I just poked on that to make it go down. I just poked on this one. It went down a little bit, but then what happened? Came back up and floated. Okay, thank you very much. Please return those beautiful glasses to the table. And you can go sit down again. All right. Okay, results. Did any of the carrots float in the pool?
Yes. Yes.
Did any float in the ocean?
Yes.
Does everybody know when I make marks like that, what that
Yeah.
means? 1, 2, 3, 4,
Yeah.
5? Yep, okay. So we had 0 floated in the pool, and how many floated in the ocean?
6.
So we did 6 different trials, or the scientific word that we use is replicates. Replicates, that's another big word for it. But we did 6 different trials, and each time we got the same result, right? What's our conclusion? What can we conclude? We asked the question, can we float better in the ocean or a pool? What is the answer to our question? Yes.
The ocean floats more better than the pool.
Right, we can float better. Well, at least we know that a carrot will float better in salt water than it will in fresh water. So we can, I'm going to give you another big word, extrapolate or say project that conclusion onto what it's like in real life. Okay? Yes?
But in the real ocean, I don't think that people will float through the waves.
Okay, see, so that's a really good that's a really good point, and I think that that's what caused most of you to say that you can float better in the pool than you can in the ocean because it's waves. But what if you swam out and you weren't in a place where there were waves? What if you were, it was flat, or like you were out on a boat and you jumped in the water and it was flat? Then, but you're absolutely right. It's hard to float when waves are crashing all over you. But if there are no waves at all, what this tells us, if there are no waves, then you're going to float better in the ocean than you will in the pool. Does anybody have any questions? Yes.
Is fresh water like oh, never mind.
So fresh water, we call it fresh water. Fresh water is the same as like drinking water. Yes.
If it's in a lazy river, will you float better than being in the ocean because it has movement as like the waves?
I don't think so. I don't think so, but that's also a good question. And plus, when you're in the lazy river, you're on an inner tube, right? Yeah. So you will float a lot better, right? Yes.
So because if you're in a pool, it doesn't have waves that much, but if people like animals in there, they'll have waves and splashing.
I'm going to do one more quick experiment. Let me ask you a question. I have to do it because I don't think you're going to be able to do it. It's kind of hard to do. I'm not even sure I can do it. What I'm going to do is I'm going to pour the pool water on top of the ocean water. I'm going to try and make 2 different layers. And now that I know I'm like under the wire for like getting this done in a hurry, I don't know if I'll be able to do it. So I'm going to try and really carefully. I want you to think about what would happen. What would happen if you put a carrot on top of this? If I poured this properly, and I'm not shaking too much, which I'm kind of shaking right now, so I think because I'm hungry.
I think you should put it on this side.
We'll see. Okay, so what we have now is pool water on top of ocean water. What do you think is going to happen? What is your hypothesis?
I think the carrot's going to go in the middle.
Do you think the carrot's going to go in the middle? How many people think that?
I think it'll be bobbing up and down.
You think it'll be bobbing up and down? All right, here's what we're going to do.
I think it'll be on down.
Let's see what happens.
He already did it.
Carefully place this on top.
Guys, sit down. I can't see. Wait, you see the middle. She correct.
Is we just combined those 2 experiments. We put the pool water. We know that in the pool water, the carrot went down to the bottom. And we layered that, I very carefully layered that on top of the ocean water, and we knew that the carrot floated on top of the ocean water. So what happened was, when it went down through the pool water, it sank, But when it reached the ocean water, it floated. So there you are. Okay. What would happen? What do you think is going to happen if I mix it? What do you think is going to happen if I mix it? Who hasn't, here, have you been up yet?
Yes.
Did you come up yet? Who hasn't been up here yet? No, who hasn't come up? Didn't you you came up already? Didn't you come up to the front?
Me?
No, you. Did you come up to the front already? Yeah? Come on up. Oh, I know. I'm sorry. Do you mind putting your finger in that? It's just salt water and fresh water. And swirling it around. All right, so we're mixing that up.
It's weird.
Now what do you think is going to happen?
It's gonna sink. It's gonna sink.
I honestly don't know. Okay, that's good. Okay. Who hasn't had a chance yet? Go ahead and place it on the top. Let's see what happens.
I can't see.
It's salty. So it's still kind of salty, okay? It's still salty. You want to push it? Somebody say, go ahead, push it. Push it, push it. Oh, it's still floating. Good job, Megan. Good job, Miss Conklin. Okay? Because it's still salty water, so it is still going to float on top of that. Yep, okay? All right, so remember, we think about the scientific method. We wanted to find out if we could float. Okay, put your hands down. Put your hands down. We wanted to find out if we could float better in salt water or fresh water, in an ocean or a pool. We developed a procedure, a way that we wanted to test it. We gathered together all of our materials and supplies. We had only one, the V word, variable, one variable. And then we ran our experiment several times. Those several times are called what? It starts with an R, replicates. So we actually had several replicates. We ran the experiment 6 times, which is really good. And each time we got the same result, and that led to our conclusion that we float better in rather than the pool, unless there was like lots of waves in the ocean, right? What's your name? Nathan pointed out some other factors that might affect the outcome of that experiment, okay? That's the scientific method. All right, we're going to go through our procedure now. Does anybody remember what the first step in the procedure is? You're over there with Miss Conklin. First step is we're going to pour 50 milliliters. I'm going to put 50 milliliters. I'm going to come up to here. Where's the 50? There's a 50. It's easy to do it if you kind of go down like this and pour it. That way you can see where the water is. Okay? It's hard getting up. Okay. And then you want to do the same thing for the pool water. Put in 50 milliliters, pour it in there, and then pour it. Okay? Can you do that? All right. It's just water, so. And sometimes it's easy to hold. Yeah, that's right. Hold the. Ooh, wait. I'm going to go up to 50. 50. Good deal? Here's what we do.
So then what are you guys gonna do?
Good.
So from there,
Okay. Okay, now go ahead and pour it into the beaker. Oh, we got yep. Oh, sorry.
you guys can take your glasses off and we'll put somebody else up there, okay?
Okay. Ready? Okay.
Good job.
Okay, take off your glasses, please. You can go sit down. Thank you for your help. All right. Okay, so now, do you know what you're going to do now? I want you to carefully place the carrot. Try not to drop it, although it's going to be kind of hard to do. But try and place the carrot on top of the water. Okay? Don't drop it, just put, okay.
It's floating.
Drop it. There we go. Okay. Okay, Okay, what happened here? This is the ocean water. This is the pool water. What are our results here? All right, let's see. Did anything, thank you. You can take off your glasses and be seated. Thanks for your help. Okay. Did any of the carrots float in the pool water? Pool, ocean, pool, ocean. No. No? No. Which ones floated in the pool? Here's the two pools. Does that look like it floated? No, it sank. How about the ocean? How many? How many? Okay. Let's repeat the experiment. Make sure that this just wasn't a, or an anomaly, a fluke. Oh my gosh. Okay. All right, what do we do? Remember what we did on the last one? You want to pour 50 milliliters of water into the graduated cylinder. It's easy if you kind of like hold on, kind of bend down like that so you can see where the 50 is. So you want to pour the ocean water in here and do the same thing. You want to pour the pool water in up to that water. Now go ahead and you can pour from the graduated cylinder into the beaker. Okay? Carefully pour it in. Thank you very much. Please take off the here. There's a couple there. Okay. Okay.
Why can't we use the same carrots that we used before?
Why can't we use the same carrots that we used before? Does anybody know why we can't use the same carrots that we used before? Why? Right, so we want to make sure that we're doing it exactly the same. The other carrots that we tested before, at least the one in the pool water already sank to the bottom, and the one in the ocean water is on the top, and it might have ocean water on it, and that might affect the outcome, the results of the next experiment. Oh, I'd have to wear both of them. You both have the same kind. Are you sisters? Oh, okay. All right, so really carefully place the carrot on top of the water, okay? What did yours do? Sank. Okay. Okay. Okay, take your glasses off and please be seated. Thank you very much. Okay, what are our results from that experiment? How about over there? Did it in the pool? Any of them float in the pool? How many? Any of them float in the ocean? How many? Okay, not looking too good for floating in the pool. What are we thinking so far about our hypothesis? Should we do it one more time? Yeah, because I have to do all boys this time. What's the first thing we have to do? We've already done this twice. Take the water and pour it in. How much are we going to put? 50 milliliters, okay? So it's good if you kind of bend down, you want to go up to that mark there. Okay, bend down a little bit, hold on to this, and you can pour it right in there. You're going to come up to that line that says 50, okay?
Next job. Okay, then what?
Who hasn't done it yet?
Good job.
Okay, go ahead and pour this in here. Pour that in there. In the pool. Okay. All right, very carefully now. Put the carrot on top of the water.
Still sinks, huh? Yours float?
Okay, what happened? Oh, you sang. You sang. What happened here? You floated, right? Okay, thank you.
You guys can take your goggles off and go sit down.
Take off your glasses and be seated, please. Okay. All right. What happened? Anything in the pool?
No!
How about the ocean? All right, so looks like we have all our results in. What's the conclusion? Was our hypothesis correct? We predicted that you would float better in the pool, right? We predicted that that carrot was going to float. So the conclusion is that the carrot float. We'll have time for one more experiment. I'm going to demonstrate one more thing if we have time. Okay. Okay? All right. So our conclusion is what? Float better in the ocean or the pool? Okay. We're going to do one more experiment. Okay, what I'm going to do now, if I'm not shaking too much, because I'm hungry, is I'm going to pour the pool water on top of the ocean water. Wait, I have a question to ask. How many people think it's going to float on the top? How many people think it's going to sink all the way to the bottom? How many people, well, what's our other alternative? Why do you think that? Why do you think it's going to go to the middle? Why do you think it's going to go to the middle? Half of it is ocean water, and what happened in the ocean water when we poured it on the ocean water? Right, exploded. All right. Okay. What I'd like you to do now is very carefully place this on the top.
No, on top.
So your hypothesis was correct, right? You thought it was going to float. Thank you. Thank you. You can take off your glasses. Okay, I have one more experiment to do. All right, what do you think is going to happen now? What we've done now. What's your name?
Demarian.
What is it? Demaritus? Demaritus?
Demarian.
Demarian stirred it up. Demarian stirred it up. Now what do you think's, here you go. What do you think's going to happen? How many people think it's going to float? How many people think it's going to sink? All right, put this on the top. I don't know what's going to happen. Okay, good job. It floated. It floated. Oh, I didn't have you put on glasses. Oh, Jesus, good thing you didn't splash in your face. Okay, why do you think it floated? Anybody have any idea why it floated? Yes, why? Okay, quiet so we can hear her answer. We stirred up the water and it mixed the fresh water and the salt water, but it was still pretty salty. And we already know that things are going to float better in salt water than they are in fresh water or drinking water, okay? All right, I think that's it.